Hey, John here. Let's talk about the map, the standard template library map. What is a map? Well, a map to me is a lot like a set. And I suspect internally they work very similarly. Where a set is a collection of keys, a map is a collection of key value pairs. So in the map, the key works very much like it does in a set. In other words, you can insert these key values into the map. But along with the key, you have the value that goes along with it. Okay? Key value pairs are what maps are all about. And just like a set, we'll see they're kept in sorted order. So if I put them in, any old way, if I traverse the container from beginning to ending, what we'll see is they'll be printed out in order, sorted based on their key values, peach, apple, pear, and so on. Obviously, apple here I think would come first. They're not sorted by the value field, they're sorted by the key fields, all right? And just like a set, you can have, you cannot have, I should say, a duplicate key. So if I have a blueberry in there already, regardless of the value, okay, here's a blueberry key with a value of 0, whatever that might mean in this arbitrary abstract example. If I try to insert another blueberry whose value is 999, that's not allowed because the key is already in the map. I can have two things with the same value, though. Right? See up here, I've got I've got a plum whose value is 4. There's nothing wrong with that. But grapefruit, that value is 4 as well, because the keys are different, not the values. The values are not of any concern whatsoever to the map. It only cares about these keys, all right? So if we compile and run this, and I insert all these things, and then print it out, what we'll see is they're printed out in alphabetical order, because that's the key of this thing is a string. So when I create a map, the first field here in the template argument is the key. The second one is the type of the value. So let's run this before we look at the do insert function in some more detail, all right? So if I run this, what we see is the insert taking place, and we'll look at that in a minute. After the insertions are done, it says, hi, I have 9 elements, and here they all are. The point of looking at this now is that you can clearly see these are sorted in order based on the key as a text string. All right, let's look and see what this is doing here. All right, now, every time I want to insert something, I wrote a little helper function called do insert. I pass it a reference, as we'll see, to the map. And I give it the key as a string, and I give it the value as an integer. So let's look at this function up here. You'll see some stuff commented out. Let's start with the nasty, ugly version, and then upgrade to the super simple version. A little one step at a time here. So what is this thing doing? It needs a reference to the map whose type matches the one that I created down here, okay? So this is the standard map string, and I just cut and pasted that up here, all right? And I want a reference to it because I don't want it to make a whole copy of it. If you leave this out, right, it'll make a copy of the map. You'll insert something into the copy of the map. It'll come out down here. This function will return, and then that map will be thrown away, and you will not have ever modified it any way the one down here. So clearly, you want a reference to that thing. My string, or my key rather, is a string. And whenever you pass a string to a subroutine that doesn't need to modify it in any way, you really want to do it like this. Tell it, the compiler, because I'm not changing it, so declare it as a constant and get a reference. If you get it by value, again, it has to make a whole copy of it, only so this guy can use it and then throw it away. If you take it this way, you get to use the one that's in the call stack over here, and you don't have to worry about all the extra copies. This is the sort of thing that slows code down if you don't do it right. The value is an integer, and there's no way to speed that up any better than just pass it in anyway, so that's the way that one works. All right, so here's the brute force, old school way of doing this. What happens? Well, the insert function on a map, the method, let's look and see how that works. I'm over here at CPP reference. I went and found the map container, and the usual down here. You got a bunch of methods in the doc on how they all work. So here's the insert method. for our friend the map. Okay, so there's all ways to do this. We're using this one up here, the simple one. You can do other things if you want, but the bottom line is that just like the set, right? Look at this. It actually looks exactly like the set. You've got an insert method that returns this standard pair, and the pair returns an iterator that's referencing the element that has just been inserted, assuming that it was inserted, and then it returns a Boolean that's true if the insert worked correctly and false if it did not work correctly. Notice the value here. We don't put a key and a value in here. It says value. So that might seem a little bit confusing. Let's put some light on that. What is the value of the thing you're trying to insert? Notice I got one thing down here, right? Because I pissed it out. Well, that is a pair of fields, okay, of items. So I have to create a structure. There's a thing called a standard pair. We can go ahead and look at it. It's right here. It's a template class. It's really a simple template class. What it is it's a struct that has two fields, and they have two, different types. They could have the same types, but they can be different, is the point. So they have two different template parameters for this. Down here it says, look, it's going to have a member called first, whose type is T1. And it'll have another member variable called second, whose type is T2. All right, no big deal. You can create them if you want by calling this makePair function. Or you can do them yourself by declaring one like this and just assigning those values. So the first is a string. So I can just assign it the value of my key up here. The second is going to be a type int field, and I need to put the value for the thing that's going into the map into that second field. I can then say, well, essentially I can then call insert and pass it this pair structure. Now insert, just like the set, returns a pair, and I just said it returns an iterator that points to an element in my set. Now this is actually what those things look like. All right, now this is a lot of typing, and it's annoying to have to type all this in and get it just right every time, which is why we use auto, and I'll show you the auto. This is what we do down here. So, and doing all this is also annoying, all right? So this is very explicitly created up here, all right? Let's do it a little bit more modern way down here. Oops, bring this one in and throw this one up here out, okay? So this one lets us focus on our problem more than the data types that are involved, okay? Because of all the templates and stuff, things can get very, messy in your code. The compiler, because makePair is a template struct, it can automatically figure out how to create the structure based on the types of the key and the value. And that's exactly what it means to construct a pair, right? If you come down here and you say, oh, what do the constructors look like? Oh, I scrolled past it already. Here we go. Here's the constructor for a pair. Well, I can create one and pass it these two values. The compiler will use the types to figure out how to create a struct with the corresponding types and all that stuff. All right, so this is just a little bit of a review in case you kind of hazy or forgot how templates work, all right? Because there's a lot of that going on in here, all right? And it gets much more interesting as we go. So in other words, I can create a very simple one line of code to create a pair that, with the proper data types that just simply match the values of these arguments here, which are given up here. They're passed into my subroutine, all right? You can compile that one up, and it'll do the exact same thing. Why? Because that's the exact same code. Notice the auto R on the way back from insert here, rather than this giant thing of data type, R. It works the same either way, right? The compiler says, look, I'm not going to type all this stuff in. You figure it out. And it says, all right, I'll figure it out based on what comes back from this this template member function, right? A member function, I should say, from this template class, which is one of these, okay? So I don't have to type it in because the compiler could figure it out on its own, right? That's what that's doing there. Now, we can take this one step further. Now, this is a little more subtle. Okay? I don't have to even tell it that it needs to be a pair and pass it in the values like this. I can do this. All right, so what is that and how does that work? This notation, I find it a little awkward when I look at it, especially if you smash everything together like this. If you work with somebody that likes to mush everything together like that, it starts looking kind of crazy, all right? At least to me, I don't know, all right? So I will space it out for you. We can keep an eye on all the little pieces here. So what is this? This is a curly brace initializer for a thing of some kind. You've seen this before while initializing arrays, and it turns out you can also use this to initialize the values of a struct, which is what is important right here, okay? Now, if we look at the insert member function of this template map, and the compiler sees all these different ways, all these different insert methods, and it tries to find one that it can use based on the types and quantities of the arguments that are passed to this member function. Now, we passed it one argument. It is this curly brace initializer, all right? The compiler knows that that either has to be the elements of an array or the field values of a struct or a class. It knows pretty quickly it's not an array because it knows that the key and the value have different data types, so it can figure that out right away and know that it's a struct. But even if they were all the same, it can still kind of figure out what's going on. In order for insert to work, the value type reference here has to match the type of the map that was created in the first place. All right? So this value type has to be a struct with the type of the key and the type of the value in it that went into the map in the first place. So the compiler knows it has to force this thing into being one of these pairs with two fields that have these types, all right? And what we've given it is the initialization for that thing. So the compiler can figure out on its own that it needs to create a standard pair, set the values to these things, and then pass a reference to that into insert. So normally when you're inserting things into a map, you would do it like this. You don't want to write. You certainly don't want to do it like this every single time, right? You could do it like this, and it depends on your situation. You might actually already have a pair from some other operation that you could just pass in here. But if you need to create a pair while you're inserting, this is the preferred way to do it, all in one line of code. And then the return value is, look, just figure it out and become whatever type it needs to be to ingest, to receive the return value from this member function, right? And that'll be an iterator of some kind that is appropriate for the map, right? And then this Boolean. Now, we saw this basically when we were looking at the sets, because when you insert something into a map, it's really ultimately, it's returning the same kind of a situation. So when this pair comes back after an insert, it has this first and second field, right? The first field is an iterator, and the second one is that Boolean. So what I'm doing is printing out, here's the key that I just tried to insert into my map, and I'm going to write justify it and so on. And then I'm going to say equals, and then I print out this Boolean value, all right? So every time I do an insert, what it does is it prints out the key, and it doesn't print the value. It prints out whether it was successful or not, and when it was inserted, all right? We can see that in here. I guess we don't have to run it again, but why not? Now that I've made a mess in my screen. Okay, so what happens? I insert the peach, apple, pear, blah, 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 blah. These all succeed because the Booleans are true. Blueberry. The second time I try to insert it, it's a duplicate key, so it fails. All right? So when I'm done with all that, I printed them out, and there's 9 in here. You'll notice there's one and only one blueberry. You can't have duplicate elements in a map. Okay, so there's the walkthrough of the high-level bird's eye view of what's going on there. with a map. Let's look at some more stuff, okay? You can have duplicate values as long as the keys are unique. You cannot have duplicate keys. So that part's the same from before. This part's the same. I print it out. Now, how do I remove an element? Well, you do remove them a lot like you did, again, with the set. The set are just removed by their values. But a map is removed by the keys, all right? So the key of a map is essentially the value when you're working with a set. So I'm going to have a do erase helper, just like I had the do insert. And I want to erase the grapefruit. I want to erase the XYZ. And there's an example of, oh, I'm deleting something that's not in the map. So let's go back up here and have a look-see at how this works. As you can see, I got rid of the extra junk, and it's down to just the simple variant here. And what happens when I do an erase? Well, you do it just like you do it with a set. You just simply say, hey, erase this key, please. And what happens when erase returns? All right, let's go find the right page for that. I can delete all this extra junk. So we're back here to the map template class. We want to erase elements out of our map. And we have different ways to do it. We can send erase an iterator and say, erase the element that this iterator is pointing at. Or I'm calling the one down here, erase the element out of the map whose key is the value that I'm passing in, right? So I have to pass in a thing of the correct data type. Again, pass a reference to a string if you're going to just use it, if you're just going to read it and throw it away. So I want to erase that. When I'm done, I'm going to print out what? Erase returns, when I call it like this, it returns this size type. Okay, which is the number of things that have been erased. We saw this with the set. And that is then going to either be 0 or 1, because in a map there can only be one thing with any given key. So what we should see, if it succeeds, is a 1. And if it fails, we should see a 0. And if you look at the program here, what does it do? Is the keys, he prints the set out. He then says, I'm going to remove the grapefruit, then I'm going to remove the XYZ, and then I'm going to print it out after those two removals are done. So it starts out the same way as the other one, complete with the, I don't want to insert an extra blueberry, print them out. I got the 9 elements we already saw before. I want to remove a grapefruit. That succeeded, because I printed out, there was a quantity of one thing removed. Then I said, I want to delete an XYZ. How many of those were deleted? 0. This one failed, all right? We used to have 9 elements. Now we have 8 elements when I print it out again down here. Well, notice that grapefruit between the cherry and the lime is now gone, okay? So, again, very much like how the set works. But you got to keep in mind that you have these pairs of things. Instead of just one field, you have 2. All right, now what are we doing here? We're going to insert a bunch of stuff. We're not going to play games with the duplicates anymore. So we're going to insert a bunch of things. We're going to print it out. Now what we're going to do is we're going to try and ask what's in there. I need to find the things in the map. All right? Okay, so I want to find the cherry. And what is that going to do? Obviously, it's going to return an iterator due to my convention here, right? So let's look at the find member function and see what it does. I want to look things up. I want to use find. So what are our options? We can find, and we can give it a key. What's going on here? Iterator, find. This returns an iterator. The newer versions are fancier, all right? So depending on the version of your compiler, they just define it differently. But in all cases, it really works the same way, and you call it the same way. You give it a key, and you get back an iterator. What are we doing here? They give you a bunch of examples on how to use it with some sample maps and things like that, okay? Let's look at the one that I did here. What do? I say, look, I want to find the cherry. And what happens? If it's not equal to end, then that means it found it, right? Because if you look in here, it'll say return value, an iterator to the element that has the key that is equivalent to the one that I passed in. If it's not found, it passes the end iterator. This is exactly the same kind of behavior we saw with the set, right? So when I call find, it's going to return this iterator. If the iterator is not equal to the end, then I know I have it, and I can print out this second field. So what? How did I know that this looks like a pair now? What's up with that? Okay, now when we found the elements in a set and it returned the iterator to the key that we're looking for, we didn't do this. We just said star IT, right? Well, that's because a set is a set of single elements, set of single values, I should say. The map, contains pairs of things. It has key value pairs. So when the iterator comes back from find and it references one of the elements in the set, that element has a first and it has a second. It is a pair of fields. The first is the key and the second is the value, right? So when you're dealing with iterators and maps, when you want the fields that come back out of the elements the iterator refers to, you can use the pointer notation to grab the first and second values. All right. So if it is equal to end, then we know it didn't find it. So here's me finding the cherry, printing out its value, and here's me looking for some other thing that it's not going to find because I didn't put any XYZs in there, right? So let's run map 3. Put in a bunch of stuff. Map has 8 elements. Here they are. I want to find the cherry. You saw the code. It calls find, and it returns back this iterator. And we can say value equals, and then IT right arrow second. That's the value of the cherry element in the map. Okay? If I then called find XYZ, I couldn't find it because there isn't one in there. Okay? Because I checked it with that, right? Now, just like the set, there are other member functions. Let's have a look-see in here real quick. Let's back up. Basically, these are all the same members that you saw in a set. It really is. But rather than having just the keys in this container, it has the key and the value, right? We have the usual clear and all this other stuff. The in places, we'll talk about that some other time. The erase, the find, the count, even this new thing contains, which is only a few weeks old at the time I recorded this video. I'm not going to get into that. And we have these bounds. They work basically the same way they do for a set, except, but when it comes to asking about the bounds, it works a lot like the find. Okay? Remember, we're dealing with iterators that go through this container. And I can say, give me the lower bound, starting with line. And give me an iterator that points there, okay? Which is going to be what? Greater than or equal to the key I'm looking for. And then I'm going to iterate until I run into the end. And what am I going to print? Now remember, the map has pairs in it. So that is first is second. I did that up here too. Maybe I didn't mention that earlier. But when you print these things out or you interact with them, right, it makes sense. Here's the key. Here's the value. So I'm just printing out starting at this lower bound, all right? You don't look for the key and the value. You just grab it, the lower bound based on the key value, okay? So there's one that's found. Here's one that's not found, just like I showed in the set discussion earlier, all right? So again, the same ones I put in, the same just printing of all the values. And then I say, give me the lower bound starting with lime, blah, blah, blah. Same kind of thing we saw in the set, but I now have the key and the value being printed out. Find me the lower bound starting with XYZ. It's not in there, so we're done. And not only is it not in there, it starts with X, which is greater than plum. All right, so that might be a little bit subtle if you didn't remember that from the set. It doesn't matter that it's not in the map, okay? It matters that its value is greater than any other value. So let's just hack the code really quick and change it to search for something that's not there, but is less than plum, all right? Just to drive this point home. All right, so let's look for, I don't know, MMMMM, right? And you'll see it will find something, even though that's not there, right? M comes between lime and peach. The lower bound is then peach, greater than or equal to what I'm looking for. All right. Again, I went over this in great detail in the set. And that really is a summary of the differences between the set and the map. These two containers work very similarly. The only difference is the map has these pairs of things, and the iterators refer to pairs of things instead of in the set, where it just simply refers to the values of the elements in the set. All right? Well, thanks for watching. See you next time.